and welcome to this series on how to write a very simple compiler using C#. The inspiration for this series, and indeed a lot of the knowledge I ended up needing, came from a series by Imrith Lamworth, who takes you through how to write a modern compiler. And he does it using his made-up language called Minsk, and he takes you through how to parse that language, perform type checking, right up to emitting IL code from the compiler. So this is just the same as if you've compiled your program using C# or VB.NET and you end up with IL code. The final thing he then does is actually adds debugging support in. So within your IDE you can then add breakpoints to the Minsk language and actually step through it command by command and view local variables. I fancied doing something similar but on a much smaller scale, and I wasn't too sure what to do until I saw a talk by C. Brand where he writes a compiler for the language Brain. And so for those who don't know that language, it's quite well described on Wikipedia, which I've added a link to, but in effect you have an infinitely long tape, and that tape is made up of a set of cells, and each cell can contain a byte. You then work on a single cell at a time, and you have a data pointer which points to the current cell. And then you've got 8 commands in the language, so you can move which cell you're currently looking at, you can increment and decrement the value in that cell, you can output the current cell onto the screen, you can replace the current cell with a key press, and you've also got support for loops. So this is a really simple language to implement because you don't really need to worry about parsing the syntax because each symbol is only 1 character long and you haven't got variable names or anything like that, so it's really straightforward. So I've decided to call my compiler BF.NET, and I've put all the source code for that up on GitHub, and all the videos are up on YouTube. So as you can see here, I've divided it up into 12 different episodes. So this is the introduction, and then the first thing we go through is how to write an interpreter. So the interpreter allows you to run commands straight away. So for example, if I could take in a key press and print it out 3 times. So I then press letter A, it gets repeated 3 times. So the first couple of episodes are to do with writing the interpreter and just improving it and trying to overcome some limitations. In episode 3, we actually then start generating a compiler instead. So we do this by almost cheating initially by just outputting C# source files. So we're actually writing a source file as if it was like a text file with a .cs extension. And then once we've got those, we can then compile them just by shelling out the standard .NET build or .NET run commands. Though I said parsing the language is straightforward, we do actually need to have an internal representation as a syntax tree. And we add that in part 5. So that allows us in part 6 and 7 to actually add some optimization for our language and also add some error reporting. So by optimization I mean if you have +++ in the language, instead of emitting the IL code for doing 3 lots of +1, we could generate a single IL code which does +3. And in terms of error reporting, we can also detect things such as an empty loop, because that doesn't really make any sense. It's either they've added it by accident or it's going to go into an infinite loop. So once we've done all that, we can then start getting things ready to actually generate IL code instead of C# code. And the first thing we need to do is a technique called lowering. And lowering means you're going to remove high-level constructs from the language. So in our case, we need to remove while loops because they're not supported in IL code. So we have to replace those with labels and goto statements. Once we've done that, in episode 9, we can actually then emit the actual IL code to generate our application. And I've split this episode up into 4 parts just to keep each video quite short. Once we have the IL code emitted, we can actually even view our program within IR Spy. So Echo here is a program that's been emitted from or compiled from a BF source file, and you can see we've actually got the IL code for each of our commands. So example, you can see here where we're moving the data pointer left or increasing the value of the data pointer. Once we have our program being emitted, we can then plug it into the standard .NET build and .NET run commands, so we can actually run them from the command line. So .NET run here is actually invoking our compiler and then running our program. And the final part, which is sort of the most satisfying, is then adding debug support. So then within Visual Studio Code, you can then add breakpoints into your program and actually step through it in the debugger. So, like I've said, I've tried to keep all the videos quite short, to under 20 minutes, so you can watch them sort of in one session. And I hope you find them enjoyable and useful.